So with these questions, we deal not just with light traveling in a medium that is not air and not a vacuum. We deal with light actually transitioning between two different media. So when we talk about angle of incidence and angle of refraction, incidence is the beginning point. It's the incident light. Once it passes from one medium to the other, that is now refracted light, so that is where the refraction comes in. Looking at this, we have an angle of incidence of 30 degrees. Angles are always theta, that Greek letter. Because it's angle of incidence, that is where the light begins. I'm going to call that theta 1. And that's the only number that we've actually been given in this question. So to find everything else we need to do a little bit of research. We need to look at the index of refraction table. We're traveling from air into water. So N1, the first index of refraction, will be that of air, which when we look it up, 1.0003. Travels into water, so that's our N2. Look up index of refraction of water, 1.33. What is the angle of refraction? So theta 2 is our unknown. Going to the formula for light transitioning between two different media, N1 sine theta 1 equals N2 sine theta 2. And just a quick note about this before we actually get into the math. This will require a calculator. You need to make sure that your calculator is in degree mode before doing any of this. As I've mentioned in the past, angles can be measured in multiple different systems, kind of like length. We have centimeters, miles, feet, inches, kilometers. Just like with length, angles have different measurement systems. There's two big ones, degrees, which we are all familiar with, and radians. Radians get talked about in depth in Pre-Calculus 30 and Foundations 30. I'll save the discussion of those for those courses because they don't actually apply to us in science. So, how do you know what your calculator is in degree mode? Look at the screen. You'll either see DEG or just the letter D, depending on what your calculator displays. If you see that, you're fine. If you see the letter R or RAD, you're in radian mode and you need to change the mode. To do that, there's a button on the calculator that says DRG. Press that as many times as you need to. Should be only a couple of times. It will change it back into degree mode. Once we've done that, we can go ahead and do the math. So fill in what we know. N1, 1.0003. Sine is not a variable, it's a function on the calculator. So sine of 30 degrees, we'll deal with that in a minute. N2 is 1.33. Sine of theta 2, which we don't know. First step, anytime we have an angle, deal with that piece in the calculator by itself. So 1.0003 is going to be untouched. Sine of 30. Type that into the calculator. That should be exactly 0.5. If it's not, check the calculator mode. Make sure you're in degrees. No calculations we can do on the right side, so we'll just carry it down. On the left, we can multiply those together. 1.0003 times 0.5 is 0.50015. And the right side is what it is. End goal is we want to know what theta 2 is. So in order to get to that point, we'll divide both sides by 1.33. Doing that on the right, we get 0.376, 05, 26, 316, and that equals sine of theta 2. And to get theta 2, in other circumstances, just dealing with straight numbers and straight algebra, we would divide by sine. That's not possible with trig functions, with any kind of functions like that. So in order to do that, we actually need to do the inverse function of sine, which on the calculator will look like sine with an exponent of -1. It's technically called the inverse sine or the arc sine. We need to do the arc sine of 0.37605 26316. To accomplish that on the calculator, you'll press the second or the shift button before you press the sine button. Then you'll type in the decimal, and you will get that theta 2 should be 22 degrees. If at this point you're thinking about sig figs and looking at this saying, well, hey, there should be one sig fig, you're not wrong. But when we're dealing with angles, angles are almost always measured to the nearest degree, regardless of sig figs. So we're not looking at sig figs in terms of finding angles, we're just going to a whole degree.